When you are given a trig equation, you are being asked to solve for an angle so that when you apply that specific trigonometric function, you get a specific ratio. To solve a trig equation involves three main steps. The first one is to determine the quadrant your angle is in using the cast rule. The second step is to determine your reference angle, alpha, and when you're given a trig ratio that is not associated to special angles, we just use our trig inverse button on our calculator. And finally, step 3 is to apply the specific quadrant modifications to find your actual angle theta. So if we look at the first trig equation, sine theta equals positive 2/3. If we think about the cast rule and we draw it in, C-A-S-T, we see that our ratio is positive. And sine is positive in quadrant 1, which is the all quadrant, and quadrant 2, which is the sine quadrant. So we are looking for angle theta in quadrant 1 and 2. Now that we know our quadrant, we just have to figure out our reference angle and then apply the modifications. So to figure out our alpha, we are just going to take the sine inverse of 2/3. And that will give us the angle that is automatically in quadrant 1. Now for our theta, we also require quadrant 1, but also quadrant 2. So let's go ahead and do that. The sine inverse of 2/3 is approximately 42 degrees. Now make sure your calculator is in degree mode for these trig equations. Now that we know what our alpha is, now we can write our corresponding thetas. So in quadrant 1, theta is also 42. But in quadrant number 2, theta is 180 minus 42. So theta is 138 degrees. So those are our two options for theta, where theta is between 0 and 360 degrees. So one full rotation. Let's try the next one. We have tan theta equals negative 15/8. So again, I'm going to use my cast rule to figure out what quadrant my theta is in. My tan ratio is negative, so we have to look at every quadrant except A and T, which means theta is in quadrant 2 and quadrant 4. Now that we know this, we can figure out our alpha. And whenever we figure out the reference angle, even if your ratio is negative, you're always going to take the inverse of the positive version. And the reason you do that is because you want to figure out alpha in quadrant 1, because that will make it easier to find your theta in other quadrants. Now, when I take my tan inverse of 15/8, I get approximately 62 degrees. And now I can do my modifications. So in quadrant 2, our theta will be 180 subtract 62. So theta is equal to 118 degrees. So that's one possible answer. Then we also know that theta can be in quadrant 4. And in quadrant 4, theta will be equal to 360 subtract 62. So theta can also be equal to 298 degrees. So those are your two answers for this trig equation. And finally, we have one more, and this is a reciprocal trig equation. If you're using a reciprocal ratio, then we want to take the reciprocal to turn it into one of our primary trig ratios. So here we're given secant, and we know secant is the reciprocal of cosine. So before I do anything, I'm going to rewrite this trig equation as cos theta equals negative, and now I'm going to take the reciprocal of 5/4 to get 4/5. Now I can completely forget about that secant theta equals negative 5/4 and continue from here. And now we're back to the basics. So let's figure out our quadrant. Here, cos is negative, and we want anything except the C and A quadrant, which means quadrant 2 and quadrant 3. And just like before, now it's time to figure out our reference angle alpha. And just like with the tan version, because my ratio is negative, I am still taking the cos inverse of positive 4/5. And when I do that, I get approximately 37 degrees. And now I can do my modifications. So in quadrant number 2, I am doing 180 subtract 37. So theta is 143 degrees. And in quadrant 3, we are adding that 37 to 180 so that we get 217 degrees. And those are our two answers. Now, in our second type of example, I have a trig equation for you. Cos theta equals -2/5. And we're going to solve for theta at some point, and we'll use this trig equation. But before we do that, I want to practice setting up all of your trig ratios except for cos, because that's already given to us. Now, if I want to set up all 5 other trig ratios, I need my triangle and I need all 3 sides so I can use my opposite, adjacent, and hypotenuse to write them down and simplify them. Now, in order for me to do that, I am going to draw a diagram. And I need to figure out what quadrant cos is negative in. So I'm going to write my cast rule. And cos is going to be negative in quadrant T. So I'm going to create a right triangle there. And S, so then another triangle. And I know cos is adjacent over hypotenuse, which means 2 will be my adjacent and 5 will be my hypotenuse. Now, we always label our hypotenuse as positive, and our adjacent side, that 2, is going to be negative because it's on the negative x-axis. And now all we need is our opposite side. And I'm going to label this opposite side x for now, and it's the same length because those 2 triangles are identical in both quadrant S and T. And in order for me to figure out what x is equal to, we're just going to use Pythagorean theorem because we know we have created 2 right triangles. So we have x squared plus -2 squared equals 5 squared. And now I'm just isolating for x squared. 5 squared is 25, and I know -2 squared is 4. And when I bring 4 over, it will be negative. So x squared is equal to 21. And in order for me to get rid of that exponent of 2, I'm going to square root both sides, and x is equal to positive or negative square root of 21. And the square root of 21 can't get simplified more. It can't get broken down into any special angles. So now I'm just going to label my triangle with the 2 sides I have. In the S quadrant, it's the square root of 21, but in T, it is negative square root of 21 because it's on the negative y-axis. Now that I have all 3 of my sides in both triangles, I'm going to set up my other 5 trig ratios. And I'm going to start with sine. So sine theta is equal to, and we know sine is opposite over hypotenuse, so I'm just going to go to my triangle, and I'm going to label my side lengths. So opposite is that root 21. Adjacent is the -2, and the hypotenuse is the 5. So if I want to do opposite over hypotenuse, I can see that my opposite is both positive or negative square root of 21. So I'm going to present both options, and hypotenuse is 5. Now this is fully simplified because I have no problem with the radical being up in the numerator. Cos theta I don't have to write because it's already given to me. So I'm going to jump to tan theta. Tan theta is opposite over adjacent. Opposite is positive or negative root 21. And adjacent is -2. Now I am going to simplify this because I don't like the double signs. We know a positive divided by a negative is negative, and a negative divided by a negative is positive. So my tan theta can be positive or negative root 21 over 2. It's just unnecessary to keep the -2 in the denominator. And next, I will do my reciprocals. So I'm going to start with the reciprocal of sine, which is cosecant. So I'm going to take that ratio that I have, plus or minus root 21 over 5, and I'm going to flip it. Now the plus minus, I'm going to keep it up in the numerator. It doesn't matter where it is as long as it's somewhere in your fraction. And the numerator will now be 5, and the root 21 will go in the denominator. And we know based on our radical knowledge that we can't have a radical in the denominator. So I'm going to multiply the numerator and denominator by the square root of 21. And what that does, in the numerator, I will have 5 times the square root of 21. And in the denominator, I know a radical times itself is just the radicand, which is 21. Now this is proper form. Next, we're going to take the reciprocal of cos, that's secant theta. And our cos ratio is negative 2 over 5, so the reciprocal will be negative 5 over 2. And finally, we have our cotangent ratio, which is the reciprocal of tan. So I'm going to look at my tan ratio that I simplified the signs right over here. And I'm going to take the reciprocal, so that is plus or minus 2 over the square root of 21. And again, I want to rationalize my denominator, so I'll multiply top and bottom by root 21 to get positive or negative 2 times root 21 over 21. So there are my other 5 trig ratios. Just using our SOHCAHTOA knowledge and our Pythagorean theorem knowledge to fill in our triangle fully, and our cast rule knowledge to figure out the quadrant that we are in. And now let's determine the value of theta. You can technically use any ratio that you want. I'm going to use the original equation that was given to us, which is cos theta equals negative 2 over 5. I already know my quadrants. I know I am in quadrant number 2 and quadrant number 3. And I do have to figure out my alpha. So I'm going to take the cos inverse of positive 2 over 5. And when I do that, I end up getting approximately 66 degrees. And now we can apply our modifications. So in quadrant 2, we're doing 180 minus 66. So theta is equal to 114 degrees. And in quadrant number 3, we're doing 180 plus 66. So theta is equal to 246 degrees. Now, we have one more type of example which is very similar to this one, except instead of being given our trig ratio or trig equation, we are given a coordinate on our terminal arm, which means we're not going to have options in what quadrant our angle is in. So here we're given point P at negative 4, 6, and we want to determine all 6 trig ratios and then determine the value of theta. So I am going to start off by drawing a Cartesian grid roughly, and then I'm going to plot this point. So negative 4 on the x-axis and positive 6 on the y-axis. That makes our point roughly here. And now I can create my right triangle because I'm going to label all of my side lengths. So my vertical side is positive 6, my horizontal is negative 4, and all I need is my hypotenuse. So I'm going to do Pythagorean theorem here. So negative 4 squared plus 6 squared equals, I'm just going to say x squared for the hypotenuse, and I'm going to clean this up. So 16 plus 36 is x squared, and this gives us 52. I'm going to square root both sides, and now 52 can get broken down. And remember, it is positive or negative square root of 52. And this 52, I can break it down into the square root of 4 times the square root of 13. And we know that the square root of 4 is 2, so 2 root 13. And that is our hypotenuse. Now, I did write plus or minus because that's what always happens when you take the square root. But like I said before, your hypotenuse is always going to be the positive version. So all I really care about is positive 2 root 13. Now I can go ahead and determine all 6 trig ratios, simplify them nicely, then pick one of those trig equations to solve for theta. So let's get started. If you'd like to pause the video here to try to set them up and simplify them on your own first, and then try to solve for theta using one of your ratios, by all means. Otherwise, I'm going to start. So sine theta is equal to opposite over hypotenuse. So I am going to go ahead and label. Opposite is 6, adjacent is -4, and the hypotenuse is 2 root 13. So opposite will be 6 over hypotenuse is 2 root 13. Before I rationalize the denominator, I am going to simplify that 6 over 2 to 3 over root 13. And now I will multiply the numerator and denominator by the square root of 13. That way, the radical will go up in the numerator and the denominator will be a nice whole number of 13. And it is going to be positive because we are in quadrant 2 where sine is positive. We will expect cos and tan to both be negative. So cos theta is going to be adjacent over hypotenuse. Adjacent is -4, hypotenuse is 2 root 13. And again, I'm going to simplify the 4 over 2 first. And now I will multiply numerator and denominator by root 13. So it does get quite repetitive. And there it is. Tan is opposite over adjacent. Opposite is 6, adjacent is -4, and I'm just going to simplify that to -3 over 2. Where you put the negative, it doesn't matter. Whether you keep it in the denominator, numerator, or out in front, they all mean the same thing. Now time for our reciprocal ratios. So I will start with cosecant theta, which is the reciprocal of sine. Now, I have 3 different ratios here to pick from to take the reciprocal. If I take the reciprocal of my final ratio, this radical that is in the numerator is going to go down in the denominator, and then I have to re-rationalize this. So I personally am going to pick this middle ratio because A, the 6 over 2 has already been simplified, and if I take the reciprocal, the radical will move up in the numerator and I won't have to worry about rationalizing anything. So cosecant theta is equal to the square root of 13 over 3, and it is done. When I go to my next reciprocal ratio, so secant theta, which is the reciprocal of cos, I'm going to do the same thing. I'm going to pick this middle ratio where I've simplified the coefficients and the radicals in the denominator, so when I take the reciprocal, it moves up in the numerator. So negative root 13 over 2, and I just put the negative out in front. I don't really like having negatives in my denominator. And finally, the reciprocal of tan is cotangent. So I take my simplified fraction of -3 over 2, and the reciprocal will be -2 over 3. And those are our 3 reciprocal ratios. Now, when we want to solve for theta, we can pick any of these ratios. I personally don't want to use any of the reciprocal ratios because I don't have the inverse buttons of reciprocal ratios on my calculator. And then when I'm picking between sine, cos, and tan, some people like to pick the ratio that is already positive, so maybe the sine theta ratio. I personally would use the tan theta because I don't have any radicals to worry about. But using sine or cos, it doesn't matter. It would work the exact same way. So if I'm using tan theta equals -3 over 2, I already know what quadrant I'm in, and I don't have to worry about the quadrant 4 where tan is also negative because I was given a specific point. I don't have freedom. I'm not going to have 2 possible answers for theta. There's only one option, and it's in quadrant 2. So I can jump straight to finding alpha. So I'm going to take the tan inverse of +3 over 2, which gives us approximately 56 degrees. So in quadrant 2, theta is going to equal 180 minus 56. So theta is equal to 124 degrees. And if we look at our diagram, that makes sense because we want our theta to be between 90 and 180, and it is. So in this lesson, you practiced your Pythagorean theorem, your all 6 trig ratios, and you learned how to solve a trig equation. So find the quadrants you're in using your cast rule and the sign of your ratio. Figure out alpha by taking the inverse of the positive ratio, then do your modifications.